Okay. Good afternoon. Actually, I'm used to doing, I work with a global firm, so I'm used to having to say good greetings in multiple time zones, good afternoon, good morning, good evening. But I guess here we can settle on good afternoon. This is the track following lunch. I seem to have a habit of landing on tracks right after lunch. And hopefully, well, the purpose of this track is not to allow you to catch up on your sleep. I will tell you that I would like to say this is a topic that keeps me awake at night. Well, I won't go quite that far, but it is a pretty exciting topic. My name is Tony Baer, and I am a principal analyst with Ovum. We're an IT analyst firm, and probably for most of you, it's probably not a very familiar name. We are based in London, in the UK. The majority of our enterprise client base is really in EMEA and Asia Pacific. But anyway, my focus is data management and big data. And this is basically going to be a session of both looking back and looking ahead. And actually, I don't know if any of you were, well, I hope that most of you were at the keynote this morning where my colleague, Jeff Kelly from Wikiben was interviewing Aaron Murthy and Doug Cutting. I was actually really quite touched by this meeting of frenemies. But basically what it showed was that this platform, Hadoop, as new as it is, has a history. And that history has actually a lot of parallels when you take a look at the emergence of other data platforms. And we take a look at the emergence of BI and data warehousing back in the mid-90s. And I'll go through this in the rest of the talk. But what's interesting about this, and we'll get into this in a couple slides, is just how, in some ways, I think that maybe in this industry there's really nothing new, except that there's everything new. But these trends are familiar, and they happen for a reason. They happen not just because the technology allows it to happen, it's because these reflects the needs of you and basically and the clients that you serve. So anyway, the title of this presentation is Hadoop, SQL, and NoSQL, and it's no longer an either or choice. Okay, so this is really a session that we're going to talk about database convergence. Okay, so it's basically a pretty simple agenda. Initially, we're going to give a little bit of back history. And for those of you who read any of my posts, I just put up another one this morning. I was back in school as both a history major and a journalism major, and so anyone who has to suffer through my posts has to go through a boring history lesson first. Hopefully this lesson is not going to be hopefully not that boring. But anyway, we're going to initially look at sort of the background of how data platforms emerged and why we're seeing a convergence right now, and then we'll finish up by looking at some of the loose ends, and hopefully we'll have a little bit of time left, to have some questions. Okay, well, this is what I was starting to forewarn you about, which is that history does go in cycles. I once had a professor, in college that said those of you who believe it goes in cycles are wrong, except that he was wrong. History does go in cycles, and it's just incredibly true, in the database sector. If you take a look at where we started back in the 70s, basically, I mean, databases really, there really is no such thing as a database. There was a place where you put information in, and it was generally commingled with a program. These repositories of data tend to take the form of file systems, or in some cases they had some organization to them, where they might have been either hierarchical or networked. Well, basically in the 70s, Codd and Date came up with some ideas that said, wait a second, wouldn't it be nice if we can think about getting to data by looking at the logical relationships between data as opposed to having to know where on the machine this data sat? And that was really the whole, the whole impetus behind the birth of the relational database, which is now, I think the first paper was like about 1972. So we're talking about a technology that is over 40 years old. I was still in school. In fact, I don't think I was even in college then. But anyway, and so it was very interesting because during the, when this technology began to become commercialized in the 80s, actually IBM, which invented it, didn't initially see the potential of System R. And so some folks, Larry Ellison and some of his colleagues said, why don't we seize on this? It was hugely risky, and basically through the 80s, SQL databases were perceived as being kind of a risky technology, just like Unix was considered a risky operating system because it was rife with bugs. The rap against SQL at that time is that this thing could not scale. It just couldn't perform well. Moore's Law pretty much took care of that. And so in the 90s, we got into this sort of perfect storm, which was brought about by a combination of Y2K, emergence of client server, and then the internet, and also basically a highly booming economy that put a lot of money into IT. And so the result of this was that with Y2K looming, a lot of organizations had to go off these legacy systems, and so relational databases, which by now became sufficiently performant, off of these very fast Unix servers. They were on the road to becoming the de facto enterprise standard. We briefly had a bit of a detour, and it doesn't really show up on the screen too well, but we had a brief detour in the 90s thinking, well, wait a second. If we're really looking at how we should represent data, well, how are developers attacking this? And there was this emergence of a trend towards object-oriented development. And so that birthed the object-oriented database. We thought this would be a more natural fit, because this is the way the logic is developed, so we could avoid the impedance mismatch. But essentially, by that point, the relational, train was basically, that train had left the station. But it's interesting how ideas come back. Hold that thought for a moment. Okay, so we get to Y2K, and whatever systems were being replaced have been replaced. And the market settled into kind of a stasis. Actually got, frankly, rather boring. It's kind of like we may as well shut down the patent office. In terms of app dev, you either had your Java developers or you had your VB or, shortly thereafter, your .NET developers. And in the database space, it was okay. It was Oracle, SQL Server, DB2. The others pretty much, kind of dropped off the wayside, except that in the web, we had this open source thing, MySQL. And of course, okay, I don't want to leave out Teradata. They've always occupied a special niche with regard to very large data warehouses. But basically, by that time, essentially, it seemed like this was a settled question. These were your de facto databases, except that as we all know with the history of Hadoop, and we got a great dose of that this morning with Aaron and Doug, that there's a whole class of problems, in fact, classes of problems, plural, that relational databases could not hack. I mean, Facebook. Their daily uploads to their MySQL data warehouse were taking longer than 24 hours. Something had to give here. And so obviously that birthed a whole new generation of lots of different types of data engines. All of a sudden diversity ranged. And actually the same thing happened with app dev languages, where all of a sudden you start seeing the rise of scripting languages, because that was intuitive to developers. And basically these new engines were not only intuitive, they were practical for solving the problems at hand, which were dealing with data that was coming in ridiculous volumes, data that was basically highly variable in structure. And guess what? We had this technology based on internet data centers, and sort of basically an architecture that folks like Google perfected, which is put a bunch of cheap processors and just line them up for miles. And don't worry about something goes wrong, where you assume failure will happen. And that's basically where you saw SQL, or I should say NoSQL and Hadoop emerge. And guess what? If you fast forward to the present, we're kind of back in a way to where we started, except that things have changed. This is just, I'm not going to spend a lot of time on this. This is just the detail. This is just, gives you just some of the detailed history. If you see the video, okay, you can take a look at this, but basically the use for this is basically if you're trying to fill out a quiz. But basically this shows you essentially the timeline of all these databases. And the next one here, and unfortunately I had some shading here which doesn't really quite show up, but basically if you take a look in the period around the 2005 to 2009 time frame, it was the period where we thought that we may as well shut down the patent office. Today, basically, you're seeing the birth of an ecosystem. I mean, we've started to see traces of this last year, but take a look, for instance, at the turnout on the exhibit floor. I think Hadoop Summit had like 60 or 50 or 60 exhibitors last year. This year it's like close to 90. Pretty dramatic growth. So we're really starting to see a real ecosystem. But so the opportunity here is that we now had all these new different weapons at our disposal. And that was really cool. In other words, we were no longer bound by the limitations of the SQL database. But what happened was, as we started to get all these new capabilities, so we can now sort of expand our sort of our envelope, so to speak, we started creating these new silos. And these silos were basically delineated by technology. So basically, with the SQL database, if you're doing ACID transactions, that's where you did it. BI and basically routine BI and query and reporting. If you had an application, if you had basically repeatable needs and you needed basically guaranteed service levels, you did it in a relational data warehouse or a data mart. And also, to varying extents, true with basically more advanced analytics, even though that was where we started to see the change. Then we started for a while, and I had some conversations with some folks over lunch about this, and I'm actually sort of wondering if this category is about to fade into history. But we had this new category of database emerge about 10 years ago, which basically my colleague Matt Aslett over at 451 gave the title NoSQL databases. And there was no single common thread to all this in terms of, because there was a wide variety of designs. But basically the idea behind NoSQL was, let's try and see if we can re-engineer a SQL database to get around the scalability and performance limitations. And so we did things like putting columnar architectures, flatter indexes. We started doing some very neat tricks with data compression and data skipping and so on and so forth. And each of those platforms had some different mix of those capabilities. But the idea was that you could stretch the envelope of what you could do in a SQL data warehouse. And that was cool. Except, as I said, I think this category is starting to kind of fade as it gets absorbed. And that's going to be part of what the trend we're talking about here. But then you saw on the right side all this new breed of databases or data platforms. Database is really not the right term in a lot of cases. That was outside of what we call SQL. And we started to use this term NoSQL. And that the meaning of that term, which originally was NoSQL, then started to mean not only SQL. That was a category which became very broad and referred to a number of different types of platforms. Actually, at one time, Hadoop was considered to be a NoSQL data platform, except now when you think NoSQL, Hadoop is its own separate category. But even within NoSQL, and I'm grossly oversimplifying here, you had these key value stores, which were for very simple data. You had JSON stores, which were for more complicated document data. And guess what? Remember that brief detour that we had with object-oriented databases? Well, it's not object-oriented, but it's taking a lot of the advantages that we hoped in objects, which is that to represent data in its natural, in basically the way that it naturally represents itself, but without worrying about mechanisms like polymorphism. Well, that's the JSON database, and so the most popular ones use, of course, JavaScript, which basically almost every web developer knows. So, I mean, it's no wonder that basically that platforms like MongoDB have taken off like wildfire and become essentially the MySQL, the equivalent of MySQL to this new generation of web developer. And of course, we have the reason why we're all here today, which is Hadoop. But basically, each of these things were used for different purposes. As I said, NoSQL was used for a lot of advanced, very highly scalable analytics. The NoSQL stores, well, some of them were very basically read-intensive, especially the key value stores, or I should say, very good at being write-intensive. You had the JSON stores, which were very good at reading data, maybe not necessarily writing data because they tend to be more complex. But of course, this all varies by platform. And so they were basically, in general, and it's kind of hard to put one sort of common thread around how they were all used, but the most common, probably the lowest common denominators, they tend to be used for operational decision support, kind of where you need to get information on how to basically update a user profile, and based on that profile, basically, here's the next best action. And these data stores often work in conjunction with, transactional databases, or they may in turn, work with Hadoop for deeper analytics. And one of the more popular use cases I'm starting to see emerging is where you see kind of Mongo as a front end in that sense, kind of like a front end database for current, for basically operational decisions, backed by Hadoop, which gives you, the deeper analytics. We're starting to see that a lot more, especially amongst our client base. But anyway, as I said, the problem is that the result of all this was that you ended up with a lot of these silos where you did certain jobs in certain data stores and never the twain shall meet. And it's nice to have all these capabilities, but for you as an IT organization, that it kind of complicates matters because you basically have to have lots of different specialists, you have lots of different platforms, you're trying to enforce policy over all this stuff, and it just ends up becoming a tangle of spaghetti. And so that's kind of sets the stage for really, the heart, kind of cutting to the chase here. Kind of the heart of all this, which is why and how is this convergence happening? And it is happening. Okay. Let's look back basically at the characteristics that basically, that you look for in various different workloads, I should say. And admittedly, I'm kind of this chart, I'm at risk of oversimplifying things, but basically, let's just start on the left-hand side, which is that you have this category of exploratory analytics. So maybe basically you're trying to identify what the problem is, trying to see some emergent trend, or you're doing, let's say, some sort of modeling. Now, I haven't necessarily said in terms of what platform you're doing this on, because take the example, the use case of real-time credit scoring. Now, if you think about it, most of these companies, like when you call up a credit card company on the phone, an 800 number, and you're trying to get credit on the spot, do you think they're actually computing your profile in real time and coming up with this model? No. What they're doing in real time is they're matching you to one of these profiles that they have already modeled offline. And typically that's been done in a data warehouse, say something like a Teradata. Increasingly, you're starting to see this being done in platforms, like Hadoop. But in those cases, these types of modeling runs, these types of exploratory analytics were traditionally thought of as, well, you need to have a long time to run these things. This is not a real-time job. And so your expectation was days or, hours, or maybe in worst cases, days, or a day. Then basically we got into the, in the next sort of bucket, which would be considered to be standard reporting. And that kind of goes also, that's also a pretty wide umbrella, because that could include, let's say, like your month-end reporting, which would probably be a batch run, or it could be some report that you're trying to grab on the spot, basically in a BI and query, managed query reporting tool. So that could be anything from interactive to batch, so hours to minutes, maybe seconds. And then you get into basically what's becoming really the more popular use, because I think that outside of basically end-of-period financial reporting, I think clearly the trend is going towards more interactive analytics. And so basically you're seeing, this is basically where you have like tools, let's say like Click or Tableau, all those folks basically that are basically helping you get data almost instantaneously. And they're doing this through a lot of tricks, especially by caching a lot of data in some persistent, in-memory stores. And the secret to all this is that there are changes basically in the cost of storage media. In that we used to cache data in memory, and flash was one of those things that you use for like your mobile phone or for devices. Well, now it's gotten to the point where flash is now starting to replace hard disk, especially for some forms of transactional applications. And you're seeing that memory has gotten sufficiently inexpensive enough. I mean, it's not cheap, but it's getting inexpensive enough so that we can now think about persisting data, not just caching data. And so that changes, so that makes basically, in these very rapid visualization solutions that can reduce big data down to some neat charts, that makes these types of solutions possible. It also makes basically some of the new, if you go to the far right, the real-time applications possible. Such as streaming, and this is just a neat area. We're going to be doing some more research on this a little bit later this year, but I'm personally very excited by streaming because as someone who basically suffered through years of having to cover middleware, I was basically the poor schmo that got stuck with covering complex event processing, CEP. Talk about basically a solution looking for a problem. I mean, it actually was a neat idea, which is that there are events happening in real time, and let's see if we can parse these in quickly enough so we can basically make operational decisions. And the need for it was these were basically applications where the speed of events, the volume of events were greater than basically a human could deal with. Okay, that's a neat idea. Problem was is that the technology really did not support mass deployment. What I'm saying here is that you had a few proprietary solutions that were very complicated and very hard to use and were very expensive and worked on fairly pricey, basically SMP platforms. And so basically, not surprisingly, this market, besides the fact that it had a crappy name, I mean, complex event processing, you're naming your product and the first name is complex. That's not exactly something that hopefully was born out of some marketer's mind. No, the fact is that market was limited. But guess what? With Hadoop, we have this scalable engine. So now we have the scalable ingest engine. And there's nothing that limits Hadoop from actually ingesting data very quickly. What's neat now is two things. One is basically the availability of memory that's cheap enough. Number two, we now have basically frameworks like Yarn, which are not yet, I mean, it's still a diamond in the rough. It was a very interesting presentation yesterday from someone at Yahoo who was basically talking about some of the issues, basically trying to integrate Yarn with Storm. And the fact is, Yarn has not shed all of its batch lineage yet. But the fact is that, I mean, clearly, it's a matter of time. These things are going to get worked out. But the thing is, what's happening is that now as we can start to run multiple workloads on a Hadoop cluster without having to physically separate that cluster, we now can basically run, say, a streaming workload and not have to worry about, hopefully, if it's going to impact our MapReduce run or our Spark run. And so you're starting to see these new open source frameworks. I mean, the best, probably the best known ones would be Storm and Spark Streaming. But the fact is, what this is doing is that with Hadoop providing the ingest engine, with these frameworks basically lowering the cost of acquisition, I don't want to say this is CEP for the masses, but basically this is the much better thing. I don't even want to say it's the next better thing. It is much better, and it's accessible. And that's going to become the next killer application in big data. And so basically what we see this is that this is going to be, this is basically what we're talking about when we mean operational decision support. So again, these are applications which execute in split seconds, not necessarily with people out of the equation, but the fact is you're now getting some tools that really allow you to master real time. Okay, so just giving just a couple examples here is that one issue of all this, I said before that up till now, we've been kind of siloed by our data platforms in terms of if you have a certain problem, you have to solve it on a certain platform because that's all the technology can do. But yet, business problems cross these domains. They cross these technical domains. And I've just given a couple of examples here. Customer engagement. Now, if I look at, especially with consumer companies, we're looking at big data applications. This is probably the most popular category of application that we're seeing. At least in terms of enterprise take-up. And take a look just the different, the different ways of slicing this. You have your traditional customer 360 view, where basically, this was basically the idea of, let's take a look at how customers have interacted with us in our transaction system. So when I call up on the call center or someone calls up the call center, they have a record of your other calls so they know theoretically how to treat you. That came from your internal transaction data. It was basically largely CRM data. It was largely data from your ERP system, maybe from your logistics system. But this was transactional data, and this was an interactive application. But now, obviously, I don't have to go into, look what's happened with social networks and mobile devices and so on. But the fact is, customers are now providing a lot more data, and it's there for you, for your organizations to digest. And so obviously, you can enrich this, you can enrich that 360 view with sentiment analysis. But guess what? Until now, you had to do that on a separate platform. You did that on Hadoop. And then with engagement, so I'm basically, let's say I'm on a gaming site. And I want to make sure that you get the right experience and you're shown the right options and that type of thing. You're going to need some operational decisions, decision stored, maybe something like a NoSQL database, like a key value or a JSON database. And again, these are all aspects of the same problem, but until now you had to use at least 3 different systems, maybe more, to solve this problem. Risk mitigation, kind of the same thing. Your baseline, basically, you model transactional risk on some, let's say on Teradata or maybe more recently on Hadoop. You're enriching this by basically, again, probably using something like Hadoop to rank, let's say, the impact of external factors. So in other words, maybe you're getting market feeds, and now you're taking a look at, for instance, news headlines. For instance, Russia just concluded a deal to sell China oil and basically oil at a rock bottom price. Well, what does that do to the world market, and how does that impact the risk of basically your investment in oil futures, something like that. Ingesting this is basically, again, this is basically a classic streaming application, and then then basically the definition and act have also often come off different systems, and basically in some cases offline. But again, you're having to solve this one problem with about 4 or 5 different systems, not exactly a recipe, for success. And so basically what's happening here is that fortunately technology is now starting to solve that problem for us and starting to confuse issues a little bit. Basically, some of the trends that are enabling this convergence to happen, the convergence that you need, is that basically we see aggressive tiering, with basically new forms of storage, basically flash and memory becoming very affordable. We're seeing multiple workload types that are basically that the same data platform can now take more than one workload. We'll go into that. We'll go into that in more detail. On the horizon, we basically see that that federated query, some form of query federation. I mean, it's not a new idea, but basically understanding where the data is, understanding what type of service level you need to answer this query, understanding basically how much resource you can afford to throw at it based on your budgeting, based on whatever other constraints are happening at that moment. All these are going to enter into the decision in terms of where you actually aim this query, because you are going to have multiple platforms. Hadoop is not going to replace your enterprise data warehouse, even if it does overlap it. We'll go into some of the loose ends, at the tail end. But anyway, so here's some examples of what's happening. This is on the SQL side. IBM DB2 is what they call an architecture which they cleverly call blue, but it's kind of neat. It adds basically columnar data, data skipping and advanced tiering. Basically, columnar pretty obvious, which is very good for analytic queries. It's not replacing their row store. They're just adding it to DB2. They're also adding some pretty in conjunction with this column store and in conjunction with the compression. They're doing some data skipping so that, guess what? Besides the fact that we're compressing this data, we'll now be able to route this query so you don't have to go through and scan irrelevant data. In turn, and as I said before, advanced tiering, so they're basically doing some very intelligent tiering, onto various different media, whether it be flash, whether it be in memory, whatever. And by the way, this is a common thread. This is not exclusive to IBM. They also are adding a MongoDB compliant JSON store. That I thought was kind of cute. And the idea here is that you're not going to buy, it's not going to be a question of do I buy MongoDB or DB2. It's more a matter of if I have DB2, do I want to also maybe take on this workload that otherwise I might put on a Mongo system? So that's kind of going to be the common theme here. We're seeing some similar trends with Oracle, Microsoft, Teradata, and SAP. Oracle Database 12c, and I'm actually, they're actually doing some advanced briefings this week. There will be an announcement next week. But in-memory option, which they already talked about basically last fall, this is nothing that's not in the public domain, is adding some very advanced memory-based columnar and extreme compression. Again, similar theme as IBM. SQL Server has basically parallel data warehouses adding columnar indexing, and Polybase basically adding Hadoop integration with the Hortonworks platform. Teradata basically has also added some very advanced some fancy things with memory, and their Aster platform basically is starting to get into graph data, which is a very interesting play. And finally, SAP, which had been promoting HANA as basically being their 100% in-memory data store, is now adding basically taking old Sybase technology, smart data access. What they're saying is, we realize you're not going to be putting all of your data onto HANA. And in turn, Hadoop is not obviously standing still. And basically, this is probably, if you've been at this conference for the last day or two, this is going to be reviewed, so I'm not going to go into this in detail. But basically, a couple of themes that have come out from this conference, basically, is that last year the vendors were basically planting their stakes with SQL. This is how we're going to do interactive SQL on Hadoop. Because basically our clients are asking for it. Why? Because our clients have SQL developers, but they also want to take advantage of the economies of scale and the scale of Hadoop. And again, Yarn is a major enabler in all this. And again, I'm not going to go through all this, but again, what's happening is that you're seeing now the emergence of a lot of different types of workloads. Hadoop is no longer your father's MapReduce machine. I mean, when I was first learning about Hadoop, my first question was, what's the difference between Hadoop and MapReduce? Kind of a dumb question, but actually, for a long time, it's like you didn't see one without the other in the same sentence. Well, that is, if there was any doubt about that, Yarn has basically broken that, has broken that relationship, and for good, and that's a good thing. So you're seeing like all these different types of workloads that are now starting to emerge on Hadoop. A lot of open source frameworks are emerging. There's going to be a lot of choice that you have. And the fact is, some of this stuff is going to overlap with what you do on your SQL data warehouse. And meanwhile, let's not forget NoSQL here. And the NoSQL store, well, JSON stores basically, I mean, that is just becoming such a no-brainer for developers because they already work in JavaScript. JSON represents data, the type of data they work with, in a way that they don't have to sort of refactor or go through what we used to call impedance mismatch. And so there's been a huge popularity, with JSON, and in many cases being used as a front-end operational, decision system, operational decision support. And again, as we're saying, we're starting to see that JSON stores, crop up in household brand name SQL databases. Hadoop can accommodate this. It's not a specialty of it. We're also seeing some new transaction stores, and I realize that this, my talk has really not been that much on OLTP. Because when you talk about base OLTP systems, you are not going to throw out your Oracle database that's running SAP anytime soon, even though SAP would love you to throw it out and put it in HANA. But that's not going to be a big replacement market. But what you are seeing is some new transaction stores that are basically emerging to solve some new transaction problems. For instance, if you have a widely distributed internet scale transaction system, and there are a bunch of players that are basically rewriting the rules, whether it be around SQL or using NoSQL. But the idea of being able to do distributed transactions that take different liberties with, with ACID. And that's a whole other discussion. We can talk about that offline. But anyway, there's just a lot of variety happening. So what does this do? This gives you a variety of overlapping choices. What this means is that it doesn't mean, for instance, that, well, if I have a SQL data warehouse where I basically am, submitting queries and I need with guaranteed service levels, even though, let's say, my Hadoop platform can now do interactive SQL and the performance is getting better, I'm probably not going to replace it with that. I may use that Hadoop platform to perform interactive SQL, but not necessarily to replace, basically, the bread and butter queries that I'm doing every day. I just may extend the envelope on the queries that I run on Hadoop, expand basically the variety of basically interactive SQL queries. But in turn, again, you can see here it's overlapping. You can basically do JSON on a SQL database. You can do JSON on a NoSQL database. You can do basically distributed OLTP on a new SQL database. You can do deep analytics on Hadoop or SQL Data Warehouse. There are lots of choices, but each platform is still going to have its unique mix of strengths and weaknesses. So it's not that one is going to replace the other, but you are going to have more options to kind of have a more coordinated strategy with regard to where you run your analytics or transactions. Again, you'll have more options at your disposal. The question is who's going to own that logical hub? This is kind of a Pandora's box here, and it's some research that we're going to be taking a closer look at next year, which is kind of like, or later this year, which is looking at what really is becoming a federated query, because who is going to own that query? The BI tool would love to own it. The data platform would love to own it. The application would love to own it. And we're going to see, a lot of contention here, and there's going to be a lot of competition in terms of, who is actually, on what type of vendor, on what type of, what part of the software stack are you going to basically use to help you manage your queries? Because now it's not a slam dunk. It's not going automatically against one particular platform. So anyway, just some loose ends here, and I'm not going to take a long time. We can actually go through this a little more in the Q&A. Ideally, this federation is going to be policy-based, but getting there, there's not going to be one sort of grand unified, framework. I mean, that just doesn't seem to happen in the IT space. We always kept predicting that with the Galactic Data Warehouse, and that never happened. As I said before, who's going to own this federated query? But the other part and the other unanswered questions are basically going to deal with essentially, the bread and butter issues that you face running, your data platforms, which is workload management and security. Again, these are just very open-ended questions at this point. These are loose ends, and this is an area where we basically expect to see a lot more development. So with that, basically, just to kind of wrap up here, analytics is no longer going to be limited by platform constraints. You're no longer necessarily going to have to silo your analytics because this is all this platform can do. Data platforms are taking on multiple personas. Your platform choice is not going to be either or. As I said, analytics no longer siloed. The brass ring is that is going to be that logical hub, but that logical hub is not going to happen overnight. And with that, we have a few minutes left, and I'd love to take some questions. So anybody have any questions here? And don't speak up all at once. So I'll take one poll here. Oh, Jack? Okay. Well, no, I didn't say that NoSQL is not a valid category. It has been a valid category, but I just think that NoSQL databases are being absorbed by SQL databases and being absorbed by Hadoop. I should repeat the question, which is NoSQL not a category? And what I'm just saying is it has been a category, but it's really fading away. Any other questions? Okay, well, I'd like to thank you all for turning out. This has actually been a great conference. And I'm looking forward to some more great discussion between now and the end of the day. Thank you very much.